statistics, the construction industry is at the bottom of the digital transformation if we compare it to government, if we compare it to banking, if we compare it to other sectors. And this is coming not only from one side, so it's coming from more than one side. The first side is, do we have the ambition and do we have the capabilities, as Gartner say, if we want to go for digital dexterity? So yes, we do have the ambition. We want to move into digital space, but do we have the capabilities? And the capabilities sometimes are vertically integrated within the organization and sometimes within the ecosystem. I would rather say name it an ecosystem rather than supply chain, because this is how the new the technology is going on. And today, in response to that, we at Khatib Alami, we figured out this before even COVID, and COVID came as a trigger to accelerate the digital transformation in companies. But 30 years ago, we started our journey in digital transformation, and we, as we will see, and with this session and the other session that my colleague Manar will conduct in the afternoon, we believed long time ago that the world is going digital, and we need to be as pioneers as possible. So what we're gonna be seeing here today, we're gonna see some use cases. So there will not be a lot of graphics in my presentation today, because I'll be jumping into some use cases from projects that we worked on here, and we're talking about parametric design. We're talking about generative design. So the basic, let's say, the basic platform for digital transformation in engineering or in construction is the use of BIM, and we all agree that this is the case, and still now the debate is going on whether some companies use it, some companies not, whether legalization are happening to mandate this or not. So, you know, this is always in our mind. However, to go beyond BIM, so what we're going to see today is we go beyond BIM. So we implemented BIM. We implemented standardization into BIM across the company. We created a common standard. Let's say we created a BIM practice manual, and we got certified by the ISO 19650 for all 4 design centers. So we said, okay, after we implemented all this, and I'm just skipping our introduction because we have only make use of the time. We said we want to do more, and we want to say, okay, BIM is fine, so we do BIM. We work on BIM in buildings and infrastructure and mixed use, so that's fine. So what's next? So what is next is we started developing a new streams within BIM. One of them is automation. So we started by figuring out who has the capability to work as an engineer, to work as a BIM developer. So we found like 1 or 2. Then we hired some others. Then we embarked on a training program, which took us almost a year to train people who are interested. Then we discovered that within the company, there are a lot of people who are interested and are capable. And now we have more than 20 people, 20 developers, and real developers using Dynamo, Rhino, Grasshoppers, using other technologies, even C#, developing applications for BIM. And we automated in some departments, like structure department, we automated the process of structural design like 30 to 40%. So this is happening as we speak, and we're going even beyond that, and we're developing our internal in-house generative design platform. So the seeds started a few months ago, and then we have like more than one practice. One of them is on a project level, another one is on the company or on the service level. So, and the use cases that we'll do, this is one of the technology achievements that we have done. This is a digital twin, implemented digital twin project in Oman, and we've done it with Bentley, and the project is done and operational. So And this is like, we're talking about the technology, but we're talking about implementing the technology. So this is what is important. BIM, to look at BIM, as my colleagues in previous sessions said, BIM has to be part of the digital transformation strategy. It should not, by any means, be part of the IT or, because it has to be part of the vision. We need to move into digital space. So we need to implement BIM as the basic thing, basic platform that we need to have. So having implemented this, and we move to the use cases. The first use case, and I'll go simple and I'll go complicated. The third one will be more complicated. So we're talking about the first one is the Mall of Saudi, and this is done in 2018. And you will see in this project, we created like 24 Dynamo scripts, and we saved 40% of the architectural work. So we saved more than 7,700 hours if we do things manually or we do them by these scripts. So those scripts, which I will not go through them today, but I'll just give you an overall. So the saving on here, we saved almost 7,700 hours by doing automations into so many aspects of the project. The second use case is the Red Sea. And in here, there's, in the Red Sea, we have a lot of pneumatic shapes, sometimes tents or different shapes. And these shapes cannot be worked into as engineering, not as a perspective. It could not be done in Revit. So even here, we're doing a comparison, but it cannot be done in Revit. So what we have done is we needed like 33 days to finish them if done manually, but they cannot be done manually. So they have been done in 1 day. So we have 97% of saving. And this is done using Rhino, grasshoppers, and we have an architect doing this. So the beauty of it is we're not bringing somebody from the IT and ask the IT people to do it. No, we have architects and engineers working in the development to deliver the final product. So you see some of the shapes, and this is the final modeling. This is when we received it, and this is where we modeled it. And if you see, and you will see the next case, every single piece is modeled. Every single piece is modeled. So it's a 3D. We take it to Revit. We can quantify it. We can do any operation, cross sections, whatever, in Revit later on. The third case, which is more complicated, we used many applications in this case, which is the STC headquarters. In the STC headquarters, the shape itself, if we want to do it in Revit, it cannot be done. So the question, if it can, it cannot. Then the comparison also, the same comparison with if it is, let's say we assume that we can do it, but how much time we need? So we need like 1,200 hours, but we did it in 90 hours. So we saved like 92% of the work. And this is all done using parametric design. So we will see, we specify the skeleton, we build the model, and all this is done using programming. So nothing drawn. So there's no drafting in here, no modeling here using Revit. We later on take it into Revit. So each one of these, of course, we use Rhino with other applications, and we specify all the equations that we need for. We categorize and we created like 8 triangles, and each triangle follows a certain equation, and they are the same size of triangles across the model that at the end can give us, you see those, and the same angle, same size, and the same equations, the same formula used using the grasshopper and Dynamo. And then from there, of course, we moved the model into Revit. So after we finish this, we move it into Revit, and then in Revit, we develop it and add to it and then put materials and renderings or whatever. So these are the three cases that, because of the time, of course, maybe in the questions we can elaborate more, but these are the three cases that I wanted to share with you today. Thank you very much.